Well, hello there, wonderful young people. Let's use our good old-fashioned Dixon Ticonderoga number 2 to graph this wonderful polynomial equation right here. Now, I made this equation to be completely factorable because I know we need practice factoring. And for those of you not in my class, this is a pre-calculus practice problem, and my goal for any student in pre-calculus is that that's a college-bound class, and that nobody taking this class that passes pre-calculus should have to take a remedial math class. So there are a couple things we have to be good at. We have to be able to graph something like this. We have to be able to factor. If you can't do those things, you're most likely not going to be very successful, and you're probably going to have to take remedial math classes. So let's get to it. First thing we're going to do, we're going to find the degree. The degree of this is going to be 3, 4. So we have a degree of 4 because it's going to be x times x is x squared times 3x squared will give you 3x to the 4th. Now, because of that, the maximum number of turning points we're going to have is 3. Now, let's look at our end behavior. The degree is 4, so that means they're either going up both ways or down both ways. And the reason we can tell the difference between the two, the reason we tell is the leading coefficient. So we're going to have 3x to the 4th. If we multiplied that all out, so the leading coefficient's positive, so that means it's going to look something like this. We don't know what's going to happen in the middle, but on the ends it's going up both ways. All right, so now those are the clues we can get from degree. Let's find y-intercepts. To find a y-intercept, remember, you put 0 in for x. So I put a 0 there, a 0 there, 0 there, a 0 there. So see this 0 times who cares? 0 times a number times another number is equal to 0. So we have, that's our y-intercepts. X-intercepts, well, I know I've got 0, 0, because this is an x-intercept as well. And yeah, so now, to find the others, you take each factor and set them equal to 0. So we already know that one, right? 0, 0, because x equals 0. That's where that one comes from. X plus 7 equals 0. That's going to be x equals negative 7. This one, 3x squared plus 5x minus 28 equals 0. All right, now, this is where we're going to get into a little bit of trouble. I prefer guess and check. Guess and check is where, you say, hey, what multiplies to 3x squared, and that goes here and here, and then 1 multiplies to 28, and those factors go here and here. So it could be like 14 and 2, 2 and 14, 4 and 7, 7 and 4, right? And you guess and you check. So like, for example, this is going to be wrong, okay? You guess, now you would check. So the outside would give us 21x, the inside would be 4x. The difference of those has to be a plus 5, and it's not. So that's wrong. No big deal. So we write with a Dixon Ticonderoga number 2 so we can erase. What you do is you switch them. Because it's negative, we don't know the sign. We just know they're different. These two numbers are a different sign because these two numbers multiply to make negative 28. So now, check the outside, check the inside. The difference of those two is 5. We need it to be a plus 5. So those are going to be our factors. See, that would be plus 12 minus 7. Boom, done. Look at that fanciness right there. Man. Equals 0. Now we take each of these factors and set them equal to 0. X plus 4 equals 0. So here's what we got. We got 7 over 3, and we've got negative 4. So 7 over 3, that's a little bit past 2, right? So we got 0, 0. We have negative 7 from here. We have 7 over 3, and we have negative 4. Okay, got them all right there. Boom, done. All right, now here's what we're going to do. We're going to sketch a coordinate plane like this. And what we're going to do is we're going to put all of this information on this coordinate plane. So we have 0, 0. Let's see, 1, 2, 3, 4, 5, 6, 7. So there's negative 7. We have an x-intercept at negative 7. We have an x-intercept at negative 4. Let's see here. We have one at 0, 0. 1, 2, 3, 4, 5. And then 7 over 3 is just a little past 2. Okay? So we have 1, 2, 3, 4 x-intercepts. That's the maximum number of x-intercepts we could have for a polynomial of degree 4. And we said it's going up both ways. So on each end it's going like that. That's not supposed to be a straight line, it's curved, right? But you get the idea. Now, here's what we don't know. We don't know what happens between here and here. We know that it goes through this point, the graph does, and the graph also goes through this point. So the graph goes through here, 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 and here. What happens in between those, we do not know. So what we're going to do is we have to figure that out. So from here, the graph could do two things. It could turn back around and go up, or it could go down. Look, if it goes back up, This point right here, this would be a positive y. If it went down, like down here, that would be a negative y. So what we're going to do to figure out if it goes up or down is we're just going to plug in a number somewhere in between -7 and -4. And all we got to do is find the sign. We just need to know if it's positive or if it's negative. If it's positive, it goes up. If it's negative, it's down. So let's do that. So I'm going to write the equation right here above it. I'm going to do some scratch work. 3x squared plus 5x minus 28. And let's do -5. Let's do -5. So let's do f of -5. All right. So that's a negative number, right? -5. And -5 plus 7 is a positive number. Do you see how all I'm doing is writing the sign? I don't need to know what the number is. I just need to know if it's positive or if it's negative. And then I multiply them all together, and I can see if the outcome would be positive or negative. All right, so -5 here. So that's going to be 25, right? 25 times 3 is 75, minus 25 minus 28. So that's going to be a little bit over 50. That's less than 75, so that's a positive number. So what we have is we have a negative times a positive times a positive. That would give us a negative answer. So that means it's going to go down. We don't know how far down. We could guess kind of close, but we can't actually find this right here. This is called the turning point. We can't find the turning point exactly without using calculus, which, you know, this is pre-calculus. We don't know how to do that yet. All right, now, let's do one more. Let's do between here and here, right? So between -4 and 0. So let's plug in -1. Let's plug -1 in right here. So -1 is going to give us a negative number times a positive number. And then -1, so that's going to be a negative number again, because it's going to be 3 minus 5 minus 28. You see? It's going to be 3, because it's -1 squared is 1 times 3 is 3. Minus 5 minus 28, that's negative. So I have a negative times a negative, which is positive, times another positive, right? So it's going to go up. We don't know how far, doesn't matter. Now, remember, we have a maximum of 3 turning points because the degree is 4. Maximum of 3 turning points. Here's 1, here's 2. We only get 1 more turning point. So that means it can't go back up, because if it went up, it'd have to go back down. That would be 1, 2, 3, 4, 5 turning points. That's too many. The most we're going to have is 1 less than the degree, so it has to go down. There we go. Boom, done. Now, if we wanted to make sure, we could plug in a 1, and we'd see that we get a negative number as the output, right? So it'd be like 1 times 8 times 3 plus 5 minus 28. You see, that's a negative number. So it's a positive times a negative. And that would be a negative number. Boom, done. So I hope this has been helpful. It's been kind of quick. Let me know how you guys are doing. Make sure you thank your Dixon Ticonderoga number 2. Man, what a bomb pencil that is. OG. Hope you guys are having a good day. I'll talk to you later.